Hello friends, welcome to my lecture on solution of second order linear differential equation by changing the dependent variable. So we begin with the differential equation, linear differential equation of second order in the standard form, that is y double dash plus py dash plus qy equal to r, where p, q, r are continuous functions of x on an interval say j. Okay, in this method what we do is, when in my previous lecture we studied how to find the solution of this second order linear differential equation with variable coefficients when one integral included in the complementary function is known. Now there are cases of second order differential equations where one integral included in the complementary function is not easy to find. So if an integral included in the complementary function is not obvious by inspection, or we cannot determine it easily, then what we will do is we reduce the given differential equation of second order to the normal form. By normal form we means we will reduce it to a form where the first order derivative term is missing. So how we do it, let us see in the second slide. Let us put y equal to ub in the equation 1. So we will put y equal to ub in equation 1, then what do we get? So we have y double dash plus py dash plus qy equal to r. Let us put y equal to ub, then y dash is equal to u dash b plus ub dash, y double dash will be equal to u double dash b plus u dash b dash plus u dash b dash plus ub double dash. Let us replace these values in the differential equation 1. So y double dash plus py dash plus qy equal to r will then become u double dash b plus 2u dash b dash plus ub double dash plus p into y dash. So u dash b plus ub dash plus q into ub equal to r. Okay. Now let us write it as a second order differential equation in V. So we have u b double dash, first we write this term u b double dash, then we write b dash times. So b dash times what do we get? 2u dash plus pu, and then we write the coefficient of b. The coefficient of b is u double dash plus pu dash plus qu equal to r. Okay. Let us divide it by u, okay, the coefficient of v double dash. So r we can write b double dash plus b dash times 2u dash by u plus p plus b times u double dash by u plus p times u dash by u plus q equal to r by u. Okay. Now we are going to reduce this second order differential equation in V to the normal form. Normal form means where the first order derivative term is missing. So let us put 2u dash by u plus p equal to 0. Okay. So putting we get u dash by u equal to minus half p. When we integrate this with respect to x, what we get is ln u equal to minus half integral p dx. Okay. So this will give you u equal to e to the power minus half integral p dx. Okay. Now let us say, suppose so this term is now 0, okay, with this choice of u. Now let us put this as say I, okay. So if I call I, let I be equal to u double dash by u plus P times u dash by u plus q. Then let us simplify this expression for I. We can see here that u dash by u equal to, we know that u dash by u equal to minus half p. So, if we differentiate with respect to x, what do we get? U double dash into u minus u dash into u dash divided by u square equal to minus half dp by dx. Or if you divide by u square, you get u double dash by u minus u dash by u whole square equal to minus half dp by dx. Now u dash by u equal to minus half p, so let us put here. So u double dash by u is equal to minus 1 by 4 p square equal to minus half dp by dx. So let us replace the value of u double dash by u here and the value of u dash by u, and let us find a simplified expression for I. Okay. So I will be equal to 1 by 4 p square minus half dp by dx. Okay. P times u dash by u is minus half p plus q. So this is minus half p square, that is 1 by 4 p square. So we get minus 1 by 4 p square. So this is q minus half dp by dx minus 1 by 4 p square. So we get a simplified expression for I, and let us denote this r by u by s. Okay. So let us say further, let r by u equal to s. So then we shall have d square b by dx square plus I into b equal to s, where I is again I write I equal to q minus half dp by dx minus 1 by 4 p square, and s is equal to r by u, and u is e to the power minus half integral p dx. So r times e to the power half integral p dx. Now let us note here that this equation is called as the normal form. Let us say, let me call it as equation 2. The equation 2 is called the normal form. Now we can integrate this equation, or we can find a solution of this, general solution of this equation, provided r is a constant. If r is a constant, then this will be a linear differential equation of second order with constant coefficients, or I is some constant divided by x square. If you assume that I is some constant divided by x square, then multiplying the equation by x square, it will reduce to a Cauchy-Euler equation, and you know how, and we know how to solve a Cauchy-Euler equation. So we have a catch here. So let us note that the equation 2 can be solved if either I is a constant or I is a constant divided by x square. So Yes, just as we said in the beginning that only a very special class of second order linear differential equation can be solved with variable coefficients. So, there is a catch here, such equations where I is either a constant or a constant divided by x square can be solved by reducing the given equation to the normal form. So, let us see how this is the normal form. We are given the value of I, we have the value of I and s, and this is what we have noted just now. If the value of I is a constant or a constant divided by x square, then the equation becomes readily integrable. This form is said to be the normal form. Now, let us take an example and see how we will use this method. So, okay, so let us say d square by over dx square, that is by double dash, we have by double dash minus 4x by dash plus 4x square minus 1 into y equal to minus 3 e to the power x square sin 2x. So, when we compare it with the standard form, we have the value of p equal to minus 4x, q equal to 4x square minus 1 and r equal to minus 3 e to the power x square sin 2x. So, let us find first, when we reduce this equation to the normal form, the value of u. Okay, u is equal to e to the power minus half integral p dx. So, e to the power minus half integral minus 4x dx. So, this is e to the power integral 2x dx, and which gives you e to the power x square. So, we know the value of u. Now, let us find I. I is equal to q minus half dp by dx minus 1 by 4 p square. So, q is 4x square minus 1 minus half dp by dx. When you find dp by dx here, you get minus 4 and then minus 1 by 4 p square. So, you get minus 4x square whole square. So, what we get is 4x square minus 1, and here we get plus 2, and here we get minus 4x square. So, this cancels with this, 2 minus 1 is 1. So, we get I equal to a constant, and therefore, we can see from this article that this given equation is readily integrable. The normal form is now d square b over dx square plus I into b equal to s. So, I is equal to 1 and s is r over u. Okay. So, s is r over u, and r over u is minus 3 e to the power x square sin 2x divided by u. U is e to the power x square. So, e to the power x square gets cancelled and we get minus 3 sin 2x. So, we get d square b by dx square, I is 1. So, plus b equal to minus 3 sin 2x. Now, this is a linear differential equation of second order with constant coefficients. So, we can write auxiliary equation. Auxiliary equation is m square plus 1 equal to 0. So, we get m equal to plus minus 1 plus minus I, sorry. So, complementary function by c x is equal to a cos x plus b sin x, where a and b are arbitrary constants, and particular integral by p x equal to 1 over d square plus 1, where d represents d over dx operating on minus 3 sin 2x. Okay, so this is minus 3 times 1 over d square plus 1 operating on sin 2x. When we replace d square by minus 2 square, the denominator does not become 0. So, this is minus 3 1 over minus 2 square, that is minus 4 plus 1 sin 2x. So, this is minus 3 cancel and you get sin 2x. So, this way we get the value of V as, so hence B is equal to by Cx plus by Px. So, A cos x plus B sin x plus sin 2x. Now, general solution is by equal to u into b, that is u is e to the power x square. So, e to the power x square into a cos x plus b sin x plus sin 2x. So, this is the general solution in the case of example 1. Let us take one more example to make the things clear. So, we have y double dash in example 2 minus 2 tan x plus by into by dash plus 5 by equal to e to the power x into sec x. Okay. So, here p is equal to minus 2 tan x, q equal to 5 and r equal to e to the power x into sec x. Now, u is equal to, by our formula, u equal to e to the power minus half integral p dx. So, this is e to the power minus half integral minus 2 tan x dx, which is e to the power integral. Now, integral of tan x is log sec x. So, we have e to the power ln sec x. Okay. So, this is equal to sec x. So, we have found the value of u. Let us now determine I equal to q minus half dp by dx minus 1 by 4 p square. So, q is 5 minus half dp by dx will be minus 2 sec square x, the derivative of tan x is sec square x, minus 1 by 4 p square is 4 tan square x. Okay. So, this will cancel with this and we have 5, this will cancel with this, we have 5 plus sec square x minus tan square x. Sec square x equal to 1 plus tan square x. So, this is 1, sec square x minus tan square x is 1. So, this is 6. So, I is again a constant and therefore, we can easily integrate the normal form, that is d. So, thus we have the normal form as I into b, that is 6 into b equal to s is r by u. So, s is equal to r by u, which is equal to r is e to the power x sec x divided by sec x. So, we cancel this and now this is easy to integrate. Auxiliary equation is m square plus 6 equal to 0. This is our auxiliary equation. So, m equal to plus minus I root 6 and therefore, complementary function is C1 cos root 6 x plus C2 sin root 6 x, and particular integral by Px is equal to 1 over d square plus 6 operating on e to the power x. Now, we can apply 1 over f d e to the power ax formula, because here when d is replaced by a is 1 here, f d does not become 0. So, 1 over 1 square plus 6 e to the power x. So, we have e to the power x by 7. So, we have thus b equal to Cf. So, C1 cos root 6 into x plus C2 sin root 6 into x plus 1 by 7 e to the power x. This is V and we multiply it by u to get the general solution. U is sec x. So, hence the general solution is y equal to u into b equal to sec x times C1 cos root 6 x plus C2 sin root 6 x plus 1 by 7 e to the power x. So, this is the general solution of the equation given in the case of example 2. In my next lecture, I will discuss how to solve second order linear differential equation with variable coefficients by changing the independent variable. In this article, we have changed the dependent variable from y to b. In that next lecture, we shall be changing the independent variable from x to z. Now, how we get the relationship between x and z, that we shall see in the next lecture. Okay. Thank you for your attention.